Hello, everyone. Thanks for being here today, and thanks for listening to this talk. So, to give a quick context, my name is Doug Colkitt. I am the co-founder of Ambient Finance, which is a DEX, and now co-founder of Fogo, which is a high-performance chain coming soon. So, basically, what's the idea behind Fogo? Kind of the core concept is that blockchains as they exist today are not suitable for kind of the leading edge of finance. So what we wanted to build was something that was optimized for kind of the throughput and latency that like the most high performance trading applications will need. So this will basically be a quick rundown of my talk today. But yeah, so kind of the core concept is that the fastest blockchains you have today are, let's say, 400 milliseconds. That's about where Solana is. Maybe you can push it a little bit more, but compared to something like NASDAQ, right, or even Binance, right, those latencies just aren't going to get you there. And so that's not just a UX experience, even though 400 milliseconds is probably on the edge of where UX is. That's a market quality issue. And so one issue is that when blocks are slow enough, right, like whoever is the block builder kind of has this free option when they build the block to rearrange transactions, put their own transactions, watch what's going on at Binance or other real-time financial systems, and come in and kind of, right, like extract value from that. So kind of at the very edge, you see that with Ethereum, where MEV has just been kind of terrible, and some trading firms which don't like to be named have extracted huge amounts of value, but even Solana, 400 milliseconds, there is kind of emerging like MEV problem, extractive MEV problem there. So what we are looking at for Fogo is, these are basically, I'd say the rough numbers that we're looking at, subject to change leading up to mainnet. But first is we want to hit 100K TPS. And we're looking at a pure FireDancer implementation. We're not reinventing the wheel on the VM side, but we think FireDancer alone, combined with maybe some other validator requirements, you can get to 100K pretty easily. For context, Solana is doing maybe 3 to 5K in production right now. But the big thing that I'm really excited about is we have this multi-local consensus model we can jump more into, but we believe block times we can get down well below 40 milliseconds, possibly in 5 to 10 milliseconds, and that's on a true L1. So that's not a single sequencer L2. That's on a true L1 with multiple validators. You're not subject to just one party controlling the sequencer. We're working very closely with Pyth. Pyth is a major contributor to Fogo. And if anyone hasn't seen kind of what's being done with Pyth Laser, we're doing some amazing things in terms of the Oracle pricing, and that's sub 1 millisecond update. So oftentimes, the Pyth Oracle itself will lead Binance, because not only is it you have right all of these kind of top trading firms pumping their data, but oftentimes they're putting their own alphas or outlooks into that at the microstructure level. So kind of an amazing thing about Fogo is that we will have this Oracle integrated, enshrined into the chain itself, and right, you can get very, very accurate pricing. So, you can think of the context of like a DEX. You almost always have super accurate pricing at any given point. It's very hard to censor the Oracle. So it's very hard, right? Like from a liquidity provider standpoint, I can quote relative to this Oracle and be pretty confident that I'm not going to get run over or picked off or kind of all the other problems that exist. So yeah, as I said before, these are kind of three main things. First, we're going pure FireDancer. So client diversity is a controversial issue. I won't go into it. I think there's arguments on both sides. But for Fogo, kind of the performance is the top thing. And the reality is if you want performance, you can't have multiple clients. You go with the fastest client, right? Because the network can only run as slow as its largest major client. Second is what we call multi-local consensus. So you can think of kind of there's two extremes here where one extreme is, well, kind of the default is global consensus, but that's always going to introduce this latency. The other is the hyperliquid model where all the validators are in a single data center. With Fogo, we believe we can get the performance that you see from having co-located validators, but you're not tied to one specific place. Consensus can move between zones. And even if, for whatever reason, all of your data centers are blown up or seized or whatever, you can fall back to global consensus. It'll be slower, but the worst case is that you just fall back to like Solana level performance. And then finally, right, the validator set, we are just targeting a much smaller number of validators, probably around 21, but independent validators, higher requirements to get in. From the Oracle perspective, I think I covered most of this, but yeah, the main thing is having real-time data feeds pumped directly into the chain. So if you're an application on the SVM, you reference these Oracle prices, you always know they'll be at top of block, they won't be censored. You'd be very, very confident in terms of like what you're seeing as an application. Multi-local consensus, I guess, I think I kind of explained mostly with that, but kind of the big thing there is that consensus can localize if 2/3 of the validator set agrees to a specific location, and that can be a single data center, it can be a single region, it can be larger. We're hoping to target data centers, but consensus moves very easily between those locations. So quickly and easily, if for whatever reason, you know, authorities in one jurisdiction say Fogo's illegal, here, consensus can just fall over to a secondary zone, or in the worst case, global. There's World War III, global consensus, right? So you get kind of that World War III level resistance where in the unhappy path, but in the happy path, most of the time you're getting very, very low latency blocks, and that's what allows kind of these block times to hit that level. Yeah, and I'd say kind of the final point there is one interesting thing you can do with multi-local consensus. You can actually move consensus to where price discovery is happening. So, right, like most times Binance probably leads crypto markets and Binance matching engines are in Japan. So, right, like most of the time, right, Japan is probably a pretty good place to co-locate. But say there's a Fed announcement one day, right? You want to be co-located as close to that information as possible, right? So that might be in the US. So consensus can kind of move over very easily from Japan to the US or say US market open as price discovery around the globe is happening. And you kind of always, even better than kind of like NASDAQ, right? Where NASDAQ's matching engine is always in New Jersey. This can actually move around depending where the demand is from the price discovery side. The validator set, like I said, I think I kind of covered a lot of this, but the validator set, the core idea here is that this is a smaller curated set of validators. Initially, it will be based on kind of this Genesis allocation, but over time, the validators themselves will be able to curate their own set, right? So what that kind of does is prevent some of the tragedy of commons issues where, for example, if one validator's persistently front-running or kind of doing something malicious, that's bad for the network as a whole, right? It brings down revenue across the network as a whole. But right, like individually selfish for that validator. So ultimately with Fogo, if 2/3 of the validator set want to eject a validator from that, right, they have that kind of ability, right? So it allows you to enforce a lot of things directly in the protocol that maybe currently happen on the social layer. They're still happening on the social layer, but there's just kind of this protocol level enforcement. And I'll say the other thing is, right, like you might argue, is this less decentralized? But the truth is actually, in a proof of stake network, if 2/3 of the validators collude to do something like exclude another validator, they can actually do that now. It's just whether kind of that mechanism is built transparently into the protocol or not. So yeah, this is our roadmap, you know, subject to crypto level kind of timelines. But yeah, we're looking at, have a private DevNet running now, looking at a public test net end of this quarter, early next quarter, and mainnet at the end of Q2, early Q3. So super excited. It's wide open ecosystem. So I don't know who's potentially interested in building here or working with us, but I think there's going to be a lot of opportunity, a lot of users. So find me after the talk, anybody who's interested. Yeah, I'll pause there. I don't know if anybody has any questions. Happy to answer anything as well. Yes.
The validator set for 21, is that handpicked by you guys? And then from there, they say they pick someone out with 2/3. What's the process of getting anyone in?
Yeah. So initially handpicked by us. So there is a lot of path dependency here, right? If we pick 21 assholes, right, it's going to be a network filled with assholes forever. So picking 21 people, handpicked, and then over time, right, validators can enter or exit based on kind of a quorum of that validator set. And the idea is if we pick good people to start who are aligned with the network, they will hopefully stay good and kind of we want it to be pretty open, like kind of the social contract we want is, hey, if you're a good validator, you can join and you keep up. There's some bad things you shouldn't do, but that should be pretty clear, just kind of from the social layer. Yeah. Cool. Thanks.